Hello, thank you all for joining in. My name is Frank Riegel, and today I will be briefly explaining a framework that enables users with augmented reality headsets to remotely operate dual-arm manipulators in hotboxes. To get started, hot cells and glove boxes are a type of containment chamber that enables scientists to perform experiments in controlled environments. Both hot cells and glove boxes require users to be present on site and to manipulate objects inside, manually performing their experiments. At Argonne National Labs, they are developing a new type of experiment chamber they coined the hotbox. The first prototype is pictured here. This new chamber, intended to be sealed and shielded, has two capable robotic arms hanging from the ceiling. The intent is to replace hot cells and glove boxes and enable scientists with the capabilities to perform experiments from remote locations with more autonomy. Therefore, having robotic arms in a sealed chamber, we need to develop a way that would enable scientists to operate the robotic arms while outside the chamber. Specifically, we are trying to answer the question, how can scientists operate a dual-arm robotic manipulator remotely in a hotbox with full situational awareness and simple controls? In an attempt to answer this question, we came up with an idea of using a HoloLens 2 to try and submerge the user inside the sealed hotbox without requiring the users to see into or be inside the hotbox. We created software to communicate with and visualize in real time the physical robotic arms in the hotbox as holograms in the HoloLens user's field of view. We did this by using Unity Game Engine, ROS, and the Microsoft Mixed Reality Toolkit. We successfully managed to create a framework that enabled HoloLens 2 users to 1. Visualize holographic replicas of the physical robotic arms inside the hotbox, and 2. Control the physical arms that were remotely located by just using pinch and grab hand gestures with the virtual end effectors. This video is showing a recorded view from a HoloLens 2 user perspective. On the left is a virtual replica of the physical hotbox that's located there on the right hand side. As you can see, a user can successfully remotely operate the physical arms by just pinching and grabbing onto the virtual end effector from a remote location. In this video, you can see that we were able to pin a virtual window into the HoloLens 2 user's view. This window displayed a live video feed from the physical robot for more situational awareness. This was performed with a separate robot to show off the system's modularity. We also explored virtual fixtures. Here we have a user that set up a virtual plane. As they drag the robotic arm onto the plane changes color on contact. The key idea is the user is capable of going through the plane with their unconstrained hand, but the robotic arm cannot, constraining the physical robot to make straight line motions just as you would trying to draw a line with a ruler. The framework was also developed to view 3D point clouds that add more situational awareness. Future work to actually make this a practical solution for scientists has developed methods to naturally control the robotic grippers. Also, studies need to be done to understand if there are better ways to control the robotic arms. I would like to thank all of my team and those who supported this work, and thank you for joining in. Hope to discuss more in the breakout sessions.